We're going to talk about the causes of failure in yellowhead Volvo injectors valves. One of the main problems is the wear in the valve seats and the wear on the valves themselves. We'll be discussing these issues. We'll also talk about the wear on the surfaces of the intermediate plates and how to measure them. When we install a new valve, we'll look at how many microns the upper and lower actuations should be. The washer settings, how to install the lower adjustment washer, and the checks for upper and lower actuations during assembly will all be fully explained. The worn areas on the valves usually occur on the edge contour body section, where the intermediate plate presses down. The second biggest reason is that due to low-quality diesel, tearing occurs in the pin's edge contour seats, and similarly, tearing also happens in the inner seats, which causes leakage because the valves can't hold pressure. When testing for these leaks, the most important factor is that we've installed the valve in its place. After installing it in place, we pressed here with our finger. When we apply pressurized air from here, there should be no diesel leaking from between the pin and the body of the valve. We apply some diesel and then install it. Likewise, there should be no diesel leaking from the backside either. We press the valve. When you apply air pressure, there should be absolutely no leakage in new valves. But of course, in systems where the machining processes are done incorrectly, even with a new valve, you'll see leakage here when pressure is applied. In our machining processes, valves are machined using a single reference point. And our machine has an automatic matching system with micron level tolerance between the pin and the body. At the same time, during the upper triggering, automatic triggering is set on the machine with micron level tolerance. Along with this, the wear of the intermediate plate in the valve, which we call the plate, is important. In the intermediate plate, multiple reference points are also very important. This surface must be completely flat, the washer that the spring presses against on the upper surface and the base references work in sync with the rear triggering. Here, the biggest factor is, during the triggered operation of the valve, the intermediate plate's edge contours wear down as the valve repeatedly strikes the housing and body section. As this wears down, it causes the lower and upper trigger stroke lengths to change, which disrupts the fuel flow rates. To understand this, during the trigger measurement, this is a worn original plate at new one. The central hub area usually doesn't wear out. Typically, the edge contours wear down. When measuring the edge contour, we zero the reference based on the top surface, and when we pull it back, there's about 0.05 millimeters, where at the edge contour's 0 point. If the plate is not going to be replaced, this wear should not exceed a maximum of 0.02 millimeters. Otherwise, since the trigger stroke lengths are altered, it disrupts the fuel flow rates. One of the important factors while making the checks here is that we've tightened the valve's intermediate plate into place. Now we'll look at the trigger stroke length here. To check this, we secure it using a clamp system like this. The purpose is to prevent the pin from hitting the bottom surface. Yes, we've inserted the plastic piece into place like this. When measuring the trigger, we've rest the gauge. When we look at the upper trigger, let's tighten it again like this. We should be seeing a trigger movement of 0.14 millimeters. So we pulled the valve and released it. We came off it again. There is a 40 millimeter trigger movement. The required opening and closing stroke length is 14 millimeters when the intermediate plate wears out, and the value here reaches 5 or 6 millimeter. The valve's opening and closing stroke length changes, which also alters the fuel quantities. Since this affects the timing advance in the vehicle, that is, the starting point of injection, it causes the engine to run roughly or shake. When taking measurements, of course, after assembling all the coils and reassembling the injectors, we must absolutely avoid tampering with this spacer washer. It must not be lapping. Otherwise, the trigger stroke lengths will be disrupted. We've installed it in place. Likewise, this washer must also not be tampered with. We're installing the washer in its place. We've installed the valve. We're going to mount the square plate. We're attaching it to the square plate. We're mounting the valve onto the square plate. These need to be tightened firmly. When measuring the triggering, the lower part of the valve pin needs to press down. The pin part sticks out a little. We pressed it down. We need to hold it from where the coil is connected and pull it downward. When we pull it downward, we first place the trigger gauge on the surface and reset it to 0. We've found the reference 0. We're holding it from the top and pulling it down. From here, we're checking the triggering diagonally. The triggering is at 60 millimeters. Let's check again from another corner. We have to see approximately 0.16 millimeter at the other diagonal. 16 millimeter here, 0.17 millimeter. We base on 0.16 millimeter. Since we have a triggering of 0.14 millimeters, when measuring from the opposite side, we need to press the pin down while taking the measurement. Again, when we attach the clamp, we press the square plate downward. If we add 14 millimeters on top, it should come out to around 30. Yes, we got a measurement of 0.30 millimeter. 30 millimeters, when you subtract 14 millimeters, it automatically becomes 16 millimeters. So now the upper triggering is 16 millimeters. In the open position of the square plate, it should be 30 millimeters. So, what will be the tolerance for this? Now, this is where the biggest issue appears. After the assembly here, when you lift the square plate upward, we pressed it upward into its previous position. The raised position is the one when the magnetic coil has pulled it. 16 millimeter position. The standard should be 16 millimeter. This 16 millimeter value, its tolerance can be plus or minus 1 millimeter. No problem. But 16 millimeter could become 17 millimeter. It could also become 15 millimeter. But when the square plate here moves upward, the distance drops to around 12 or even 10 millimeter. What does this mean? When the coil approaches the coil base, the square plate causes the fuel flow rate to increase. A higher flow rate also leads to premature ignition. So, the standard distance that should be between the coil surface here and the square plate is 16 millimeter. When adjusting a 6-cylinder injector, all of them need to be within 0.02 millimeter. So, if we're setting the distance to 16 millimeter, they all need to be between 16 and 17 millimeter. If, for example, one is 17, another is 15, and another is 13, then the starting point of injection at the piston's top dead center gets disrupted. One will ignite early, another will ignite late, and the engine will run with vibrations. That's why, after installing the valve, the distance adjustments, both upper and lower, must be within the specified tolerance percentages. One of the things to pay attention to is the sealing washer of the fuel adjustment. When this sealing washer is tightened, its edge contours are normally compressed. Because it's compressed, when you install it in place, if you tighten it while it's already compressed, it won't sit properly inside the injector, and as a result, you'll see that the fuel flow from the valve doesn't reach the desired figures. So even if the valve is intact, if the washer is deformed, the fuel flow rates won't match. That's why we're always in favor of replacing it. This washer should be replaced and properly tightened with a new one to ensure there's no leakage or loss of seal in between. Another factor related to this is, for example, slight rusting on the surfaces on injectors that have been removed or exposed to water. Rust can also form on the magnetic coils. or small protrusions can appear on the pin surfaces, like around these edges. Normally, there shouldn't be any issues at all. But sometimes it can slip even without being overly tightened. For this, we have diamond plates available here. The diamond plates come in grit sizes of 600, 800, 1000, and 1200 of the diamond grains varies accordingly. For sanding, the appropriate plate is typically 800 grit, and when using 600 grit as well, we have the chance to clean off the rust on the surfaces by drawing figure eights on the bobbins. If the surface is cleaned and then installed, the magnetic attraction forces will be more balanced. The next step is for the technician to install the bobbin in its place, assemble the springs and washers, reassemble the injector, complete the installation, and finish the process.